Let's go to number 4. A window is made in the shapes of a rectangle with a semicircle of radius is r meters on top. As shown in the diagram, the perimeter of a window is a constant p meters. Find the area of the window in terms of p and r. Suppose this is the center of this semicircle. We label here the r and this part is r radians. Therefore, we know for the length of the rectangle will be 2r. Since we are looking for the area of a window in terms of p and r, so we will write down the area equals. We know this is the width of a window, this is the height of the window. So for area, you will get W times H plus semicircle, we got to use pi r squared over 2. So the width, we know that's 2RH plus pi r squared over 2. Since we want the area of a window in terms of P and R, therefore, let's check P. P equals, it will be W plus 2H plus circumference of a semicircle will be 2 pi r over 2. Therefore, for the width will be 2r plus 2h plus pi r. We have to figure out this h in terms of r and p. Therefore, move these two to the left side. Remember, you need to change the sign. So you have p minus 2r minus pi r equals 2h. Then you need to divide it by 2. Both sides. You will get h equals, this is a 2, p minus 2r minus pi r. Therefore, we plug into these expressions for a. You will get 2 times r times p minus 2r minus pi r over 2. Then plus pi r squared over 2. Reduce, here's 2 is gone. So you have do the distributive property here. Pr minus 2r squared minus pi r squared plus pi r squared over 2. We combine like terms for the last two terms. You will get pr minus 2r squared minus pi r squared over 2. Now let's go to 4b. Find the width of a window in terms of p when the area is a maximum. Just define that this is the maximum. So for 4b, we have to get the derivative of the area. The variable is r, so we write down a prime of r equals pr minus 2r squared minus pi r squared over 2. We do derivative. P is constant, so you get the p minus 4r minus 2 pi r over 2. That will be pi r, so we get the p minus 4r minus pi r. This is the first step. The second step, you will set up p minus 4r minus pi r equal to 0. The linear equation, we need to isolate the r on one side, so move to the right side, you will get the P equals 4R plus pi R. Then common factor is R, so 4 plus pi equals P. We divide it by 4 plus pi both sides. You will get R equals P over 4 plus pi. The width will be 2R, so you get 2P over 4 plus pi. The third step, we need to justify. So A double prime of R equals, we got to do the derivative for this. P is constant, so we get 0 minus 4 minus pi. You will get negative 4 minus pi. No matter what value for this R, your second derivative will always less than 0. So when R equals P over 4 plus pi, A is a maximum. Let's go to for C. Show that in this case, the height of the rectangle is equal to the radius of the semicircle. Basically, we're looking for the H equals R. You need to prove this. The first step, we know that W, the width, equals 2R equals 2P over 4 plus pi. And we know that R equals P over 4 plus pi. Then this is for C. We also know that it's P equals 2R plus 2H plus pi R. I want to set up this equation with the variable R and H. So for this is the one, you will figure out the P equals 4 plus pi times R, which means 4R plus pi R. So we plug this into the left side of this equation. You will get 4R plus pi R equals 2R plus 2H plus pi R. So we will isolate this 2H, move everything to the left side now. So you get the 4R plus pi R minus 2R plus pi R equal to 2H. Combine like terms, you will get the 2R equals 2H. So R equals H. You already show R equals H. That's it.